Last week, we started our topic on exponents. So, to just kind of recap, we reviewed with exponents. I'm going to zoom in now. For example, if I gave you 3 to the power of 2, we are looking at how many times 3 is being multiplied by itself. And in this case, it's being multiplied by itself 2 times. Again, to kind of recap, this little 2 serves as our exponent. This big 3 we call our base. Similarly, we looked at when we have variables, the idea is the same. X raised to the power of 2 becomes x times x if we were to expand it. Now, today we are going to be looking at one very important rule, the first rule of our unit when it comes to simplifying exponents, and it's called the product rule. Now, the product rule tells me, I'm going to keep this up just so that we can have it as a reference, that if I had x to the power of 3 and I'm multiplying it by x to the power of 2, there is a way that I can combine this, simplify it to make it easier for myself. But here's what we're going to do. Let's investigate this a little bit. If I were to expand x to the power of 3, this tells me that I'm multiplying x by itself 3 times. X times x times x. But, let me change my color. If I look at x squared right next to it, I'm multiplying x by itself 2 times. Now, it may seem as if the x3 and the x squared are just separated by this one multiplication symbol, but the multiplication symbol we see over here too. So all it is 2 groups of x's being separated. So I can just bring that down. And now, let me change this to a red. How many x's do you see being multiplied, or how many times is x being multiplied by itself now? I have 1, 2, 3, 4, 5. 5 times. So it becomes x to the power of 5. Let me write that a little bit better. Okay, interesting. Let's see with one more example, and let's see if we can form our own rule. Let's try x to the power of 4 times x to the power of 5. Again, I'm going to go ahead and expand the first one. X to the power of 4, x is being multiplied by itself 4 times. X times x times x times x. With 5, the one right next to it, x is being multiplied by itself 5 times. So I'm just going to put that little symbol down from right here. X times x times x times x times x, 5 times. And now we can see that x is being multiplied by itself. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 times. X to the power of 9. What pattern do you see here? Go ahead and pause before I explain. What pattern do you see? Hopefully you've noticed that there's a rule that tells us maybe we don't have to expand it anymore. Because what if it was x to the 20? That would be a lot of x's to write. Same thing here. We don't need to expand because the rule tells us that we can take these exponents and add them. So here's our product rule. X, let me make this a little bit more bold. The rule tells me that x to the power of, let's say, A, times, this is important, it has to be times, x to the power of B is going to be x A plus B. And this is our rule. Let's practice a little bit. I'll leave this up. Okay. Let's look at another example. X to the power of 10 times x to the power of 2. Now you always have the option to expand. This is always an option that I would encourage you to do until you feel comfortable knowing that we're just going to add it. Or if you ever get confused and forget what to do, expand it, just like we did over here. But for the sake of practicing our product rule now, we're just going to go ahead and add. So take these two, as long as they're both x's, which they are, this now becomes x to the power of 12. Go ahead and try these next on your own. I'm going to write some examples. Let's do x to the power of 3, x to the power of 5, x to the power of 4, x to the power of 6, and then x to the power of 7. Go ahead, pause this video, and try these problems on your own. Okay, so now let's go ahead and go over these. So for the very first one, 3x to the power of 3, x to the power of 5, add them, we get x to the power of 8. Number 5, again, we're going to add them, same bases, x to the power of 10. And now number 6 looks a little different because our first one is missing an exponent. However, we do have an exponent, but it's invisible. Can you guess what it is? Hopefully you said 1. X to the power of 1 times x to the power of 7, add the 1 and 7, x to the power of 8. We have 8 of them. So if you forget that x on its own has an invisible power of 1, just write it out and expand it. Here we have 1x, and we're going to multiply this side by 7. Then we can go ahead and just add. You'll find that you have x being multiplied by itself 8 times. Excellent. We're going to look at a couple more examples where we're going to now include a coefficient. So I'm going to do just a couple of these. I'm going to separate my page. And I'm going to put examples with coefficients. All right, so here's what I mean. For this problem, we're going to take a look at 3x cubed, close the parentheses. The parentheses doesn't really do much in terms of change the math we do, the procedures and steps we take. It just shows you that we have one giant term being multiplied by another giant term. So here's what you're going to do. With the coefficients, with those big numbers in the front, you are just, going to multiply them the same way you always have done with regular numbers. So again, this 3 and this 7, multiply it. Now let's see what this kind of looks like in expanded form. That might help us visualize. So the 3x cubed becomes 3 times x times x times x. We're going to bring down that other little multiplication sign. 7x, x. And now we multiply. Similar to combining like terms, but instead of adding or subtracting, we're just going to multiply because these symbols are all multiplication. So let's start by multiplying the 3 and the 7. That gives us 21. And now, how many times is x being multiplied by itself? Hopefully you said 5 times. Good. Go ahead and try one on your own now. I'm going to put it right here. Let's look at negative 8, x to the power of 7, 2, x to the power of 3. Go ahead and pause this video. Try this out. All right, let's go over this. So again, first step we want to do is multiply our coefficients. That gives us negative 16, because we have that negative, x, and then remember product rule tells us we're going to add these exponents, x to the power of 10. Before we end the video, there is one more example I actually want to do. I know, I said that was the last one, but there's one more I want to do. Quickly, just one more. I'm going to try to keep this all on the same page. So this last problem I want to look at is where we have more than one variable. Here's what I mean. So let's say I had 2x squared y cubed times negative 4xy. Let's do xy to the power of 4. So it's the same idea as what we've done at the top, or for problem 7 and 8. However, we want to combine the x's together, but then the y's together separately. So let's start by first combining our coefficients. 2 times negative 4 gives us negative 8. X squared, x, you guessed it, invisible 1, becomes x to the power of 3. Y to the power of 7. So for this one, the concepts are the same. We want to make sure we're multiplying the coefficients. But then when it comes to different variables, you're just going to group them based off of the type of variable. X is going to be added with the x's. The 3's are going to be, or the y's are going to be multiplied with the y's by adding the coefficients. Coefficients, or exponents, I should say, sorry. Coefficients go together, x's go together, y's go together. Okay. You know the drill. Try this one on your own, and then we're done with the video. Okay, let's test out 3x to the power of 3 y squared times, let's do 6x 8 y 4. Pause this video, test this last one out, and then you're done. So for your final answer, hopefully you got 18 x 11 y 6. And that's it for real this time. So go ahead, pause your video, make sure you have all the notes written down, and then we will be going over this on Monday. Please make sure you do the practice IXL. You will have a few problems just to check to see how well we grasp this concept. And I'll see you guys on Monday. Take care. Bye.